Hey, boys and girls, scholars and students. We are back, the Mashugana Metzes, to do a little science with you today. And today we're going to be talking more electricity, but specifically we're going to talk about conductors and insulators. Conductors and insulators. But of course, what do I need to do? I need to bring in my lovely assistant, Mrs. Metz. Here she comes. Welcome, Mrs. Metz.
Hello.
Don't you love her hat today? All right, so we're going to be talking conductors and insulators. Conductors and insulators. So what's a conductor? A conductor is a material that allows the electricity to move very easily through it. Really fast. A conductor just lets that electricity move really fast, really easily, right? On the opposite side of things is an insulator, So what's an insulator? It's the opposite. It's a material that the electricity just has so much difficulty getting through. It just goes so slowly. It's really tough for the electricity to get through. That's an insulator. So today we're going to experiment with a couple of different items to see if they are conductors or they are insulators. So what do I have here? I have my circuit, right? Boys and girls, scholars and students, we remember this is a circuit. Here's my power source. Here is my resistor, in this case a light bulb. And then of course we have our conductor, our wires, right? And I have them all connected. When I close this loop, my light bulb is going to go on. That means I have a closed loop, So we know that electricity is flowing through very easily if that light bulb goes on. So I'm going to add a little extra juice here so that that light bulb gets really bright. And we're going to go with our first item. Let's make sure that all my connections are still good and we have a closed loop. There we go. Perfect. All right, so the first thing we're going to do, Mrs. Metz, is we're going to try a piece of aluminum foil. So I'm going to clip on this aluminum foil right here. And then I am going to touch this other side to see if the electricity is flowing easily through. Oh, look at that. The electricity goes right through the aluminum foil, which makes it a conductor. All right, beautiful. All right, let's try something else here. Let's try a plastic spoon. Okay, not a metal spoon, but a plastic spoon. So again, Mr. Metz is going to clip on one end of the spoon and touch the other end of the spoon to the light bulb and see if it goes on. Ready? 1, 2, 3. 1, 2, 3. 1, 2, 3. No electricity is flowing through there, Mrs. Metz. So that makes this a insulator. She lost her mind there for a minute. This makes this an insulator. No electricity is flowing through it. All right, so let's move on. Let's get rid of the spoon and let's try a penny. So Mrs. Metz, let's hook this up right here. So I have a penny. I'm going to touch it again to my closed circuit. I'm going to close this circuit. Look at that. Electricity flows through the penny, closes our loop. That makes it a conductor. All right. So a penny is a conductor. All right, let's move on to, what do we got there, Mrs. Metz?
We have a rubber band.
All right. So I'm going to clip the rubber band into my loop, and then I'm going to go ahead and touch it to the other side. It's not working. Even though I have a closed loop, it's really not closed because the electricity is not flowing through the rubber band. This makes the rubber band an insulator. All right, good job, Mrs. Metz. All right, we're going to move on. We're going to try a wooden stick. Now, you think about this, a wooden stick. Do we think it's going to be an insulator or do we think it's going to be a conductor? We're going to find out. So I'm going to hook up my piece of wood here to my circuit, and I'm going to touch the metal part.
Go up a little higher.
I'm going to touch this right here, and nothing happens, Mrs. Metz. Nothing happens at all. It's not conducting any electricity, so that makes it an insulator. Okay. All right, well, we're going to try one more thing, and that is a paper clip. So we're going to hook the paper clip on right here, right on the end. And then we're going to go ahead and we're going to touch the metal, close our loop, and see if it lights up. Whoa! It did. That makes the paper clip a conductor. But you know what's interesting, Mrs. Metz? When I'm thinking about this, I see this paper clip and it's like a switch. It's like a switch in the house. When I turn on the switch, it lights up the lamp. When I open the switch, it closes the lamp. So my paper clip can act like a little switch here. I'm just going to show you one more thing because sometimes this gets confusing. We see this plastic wire. What's really on the end of the inside the plastic wire, is metal. It's copper wire. So the copper wire is what's carrying the electricity. That is the conductor. And the outside is plastic. It's an insulator. So that way when I touch it, I don't get a shock. But the electricity runs through the copper wire from one end to the other. So I'm going to show you, this is really what we're doing. There's the copper wire. I'm going to touch the other end to the light bulb and it lights up. All right, so that makes the copper wire the conductor and the plastic on the outside an insulator. That keeps us safe. All right, Mrs. Metz, that's all we have today. But hopefully you learned a little bit about conductors and insulators. Conductors and insulators. Thank you very much. Bye-bye.